Hello everybody and welcome to the class today. Well, in Module 6 and we will discuss today the subject of data-driven cybersecurity for the data analytics and statistics. We'll focus on the machine learning and the fundamentals that we need to diverse next in our journey into the data-driven cybersecurity. So for the definition here, we just need to recall that the data analytics is defined as data analytics is the science of analyzing raw data to make conclusions about information for human consumption. So basically, it's a very broad term to discuss, and in our analysis here, we will look at the network security, cyber security, and also computer system security data. And recalling from some legacy systems that we had, one of very popular system was the OLAP, or the online analytical processing. It became very popular in the first half of the 2000s, and it was based for the business analytics because they tried to see how to improve products, for example, or how to improve the delivery of products or the distribution of products. So they use something, as you can see in the screen now. They combined the logic of different aspects from different databases together and see them in more than three-dimensional view. Before that, they used to have the data source as a database flat. They started to combine different databases in something called data warehouse, and they started to do queries across the tables using some relational database management systems. However, the view of the OLAP, whenever they started to put the data in a cubic form or like three-dimensional, now we can get more relationship that we didn't see before between the data, time, and even customers. So as you can see here in this diagram, this is where the data source were, the data warehouse, and it was used to feed into the OLAP cube. From the OLAP cube, you can run different queries, and depending on the user's need, the query can be modified and see new aspects in the data. It's different than the metadata because metadata is just data about data. But now, because we changed the view of accessing the data, now we can see new relationship. And this is an example of a very popular OLAP cube where they use one-dimensional, say X was the geographical distribution, Y-axis was the products, and the Z-axis was the time. However, you can change the time here to any different aspects that you can measure. Looking at this cube, now we can traverse the cube by using some mathematical formulas. So the same thing that we did with abstract mathematics whenever we use transpose of the matrix, complement of the matrix, and so on, we can do all of them here. And by using this simple mathematical transformation, you can get new queries and see the data from different aspects. By seeing the data from different aspects, we can find more solutions that we try to solve or find hidden rows or columns or specific items inside that cube to solve what we need from our distribution or from the hypothesis that we put and we try to solve it later on. In this example, they use just country as a geographical locations, products, electrical or electronical devices, and the queue, they call it by batch time, and this is how they send. And taking it from here, you can see how we can actually go through the matrix. So we have a three-dimensional matrix. We can go drill up, which means every unit of this can be a separate unit to discuss. You can do the dicing, which select one of this cube and then go and cut even more by using very specified queries inside these items on the way Baggett will be drilling up, basically. This is terminology here. And you can use a roll-up whenever you go with the column-wise instead. You can do a slicing, which gives you a whole picture of the data combined with a three-dimensional X, Y, and Z in just one specific slot of time if we're cutting against the time plan. We can also make a transpose of the matrix, so you can turn it around, and whenever we turn, you can actually see what parameters will be affected. For example, here, if you can see in the pivot here, we use the time to increase to do prediction now. So by only using a small function in the matrix transpose, we can get new functionality that we have not been able to see it before. And remember, at the end, it translates to codes like this. So you use exactly the same function that you use for SQL Server or SQL query. Select from where, but now we use the group by keyword and union. Union to the second dimension. So this is one dimension here. This is the second dimension, and this is the third one. And the grouping just to make it in order so to be easier to follow. And you can see how the ordered by key changes by module. Now, whenever we edit the time, it will be the model and year. Whenever we did the salesperson, also you can see the model, year, and salesperson. And this is how you can get or build the three-dimensional view or the OLAP query. However, it's already legacy system. Nobody use it. However, some of the oil and gas companies still use that approach because they didn't advance to cloud system because of some security issues and concerns. And also some of these industries are really concerned about using whatever they have because they don't want to spend much more innovation in the IT field, which is a problem, but we try to solve that by using some IoT or Internet of Things approach to make it easier transformation from the systems they already have to a new systems. And by new systems, I mean cloud integration. This is one of the best modules currently. I would not say it's the ultimate one, but currently this is the best one because now you can look at your system in three phases: the edge, the cloud, and the core. Whenever we talk about cloud, some people think it's just a place where you store data, but it's not. It's just one of the aspects of the cloud that you can store your data. You have multiple copies of your data somewhere. So if something happened or there's a loss or hardware damage or sabotage, you still can get your data. But this is not the main functionality of the cloud. The cloud benefits from that you can use distributed processing and distributed algorithms to solve almost impossible problems to be solved in one machine, but now we can get it in parallel processing and save a lot of time. In our module here, you can see the edge, the cloud, and the core, and the cloud actually plays in two roles. So in the edge, this is where you get your data, or where's your database before you actually upload it to the cloud. And whenever you upload it, you use the cloud storage item. So now you apply your algorithm to the local data, you start to send it to the cloud. But before you send to the cloud, you need to make preparation for your data, to remove nulls, to remove duplicates, to remove human error from the data, from editing and so on. And this was they sometimes use the terminology of data lake to just filter out what you need to get a clean data that you can process later on. Then it goes to the training cluster. So training cluster, because the cloud can give us distributed processing functionality. Now we can use machine learning inside the cloud by using this data and try to filter it out. So in this case, they use a training cluster to take the data, and before they send it to the deployment with the repetitions of the machine learning, you can see the feedback here. The feedback used to make a better data preparation from the beginning. So usually in this step, it requires something we called supervised machine learning. So it's exactly as if you have a teacher who tells you what is wrong and what is correct and what is wrong. And this system is more suitable for machine learning, especially for digital data and cybersecurity, because we have an unsupervised method where you just give the machine all the data and let it figure out which is good and bad. And the down point of that machine can learn some wrong stuff. And if learn something wrong, it can damage the model, and now it will be very hard to retrieve back. And we really, in the cybersecurity, because of the tremendous amount of traffic that comes every single second, even while I'm speaking on this video now, it happens all the time. So how we can get the most up-to-date protection for this network? This is why we need a supervised to get a very strong model in the beginning. Then we can push it to be working on its own individually and independently from any supervision. We'll continue here. So after you get the training cluster and deployment, the last will be the archive data. Whenever you use archive data, some of them will keep it private for the company or any organization. The other one will be public. Why? Because any open source community would like to share whenever we find a new threat or a new way of hacking. We need to, as soon as possible, we need to broadcast it to all organizations around and all, I would say, the IT world, so they can know there's something new and this is a solution, or something new and this is how it looks like. Because believe it or not, if we look at the dark network and look at the hackers network, they always share new ways to steal. So as it was said, the best thing for a bad person is to happen is that good men do nothing. So this is what happens here. We need to eliminate that. So this is why you keep some of the analysis data public to increase the sharing and limit the crime after all. And whenever we look at the machine learning inside the cloud, it will be very simple, because all what we just need some raw data, pre-processing, training, detection, and output decision. This is an example of network security environment machine learning. As you can see from the left side, you can see the real network environment, and you can get some data or traffic out of it. By traffic, I mean every packet captured. It doesn't matter, is it an IDS or IPS? It's just a way to grab packets. Some of us can use even Wireshark tool to get the traffic from the network, if it's TCP or UTP or even ICMP. All of that collected will be, all of this data collected will be stored on some device on your network. Now you need a pre-processing. Pre-processing means remove the data that really doesn't carry any metadata inside it. There's no information in the data. While we eliminating some of this data of the traffic, we need to keep track of the time of this traffic, because those things that you need to actually have, if you have an attack and then you go back to see what's happening and you deleted the data before. So in my experience, it's usually advised to keep all the data in a copy on your IDS or IPS with a storage of your network security monitoring. Then you take another copy of the traffic using even a tab and send it to the ML unit or the machine learning unit. In the pre-processing, it goes with the traffic, it will drop all the hardware fault and so on. Then it will divide the data into two, I would say, pipes. One of them will carry the training data. The other one will be for monitoring. In the beginning, will depend on the training data, because the training data is what will define your machine learning model later on. This is a very important step to remember. Taking the training data, you send it to the training module. The training module here, usually it's a supervisor to look at the data and start to build the model that we need for machine learning. After you let the system run for a while, you take the other pipe, which is the monitoring data, and send it to the machine learning model. The detector system will actually map or try to learn from the coming traffic, not only by pattern matching as it used in the IDS and IPS. No, now the algorithm itself will put weights to every packet and try to see how likely this packet is an attack or it's a regular packet. After that, the detection method actually will use there to push what decision to do. And this is the most interesting part that we'll discuss in later slides in the next module. After that, we need to check on the concept of the machine learning. So providing this idea, what is a machine learning at the end? It's a useful insight for the professional because it will help to see some data or correlation between data that is not seen by human eye. Additionally, it's a predictive power because now not only you can prevent the attack, you can even predict an attack before it happens. And the use of machine learning actually depends on what you're gonna feed the machine learning. So basically, it's very simple also. A lot of people don't try to use machine learning because they just don't know what tools are available there. But now we have a lot of tools that can support our design and support how to build the machine learning model. And all what it needs is just a given data set, some knowledge of statistics, and this is why in this module, as I sent already on Canvas, a small link to a book of statistics is just to remind you about the concept of the mean and median, the standard deviation, and so on. What is the probability of occurring of events? Because we will need this basic knowledge whenever we try to do the basic analysis of the data. Pattern matching, just try to refresh your memory about pattern matching. We will not use it here, but it's an important step, especially whenever we do the preconditioning of the data or the cleaning of the data. To detect an anomaly, this is the main part that machine learning could be used right now without even writing new algorithms, because there's a lot of work done for anomaly detection in imaging and audio system, and now we can use the same module to adapt it a bit simpler to use it in the network security. And any machine learning consists of three parts. Mainly, you start with the data set. This is where you start. This is where you will get your testing data set, which is the main thing that defines the module later on. Then from there, you choose what machine learning algorithm that you're gonna use, and the platform that will run your machine learning. By using these three gears, now you have the whole system up and running for your machine learning. And let's take an example for the intrusion detection system. In this case, imagine we have an intrusion detection system using machine learning, and what we need, first of all, we need to get the data. And in our case, the data will be the network events, including but not limited to event logs, packet activity, and the time of the log, or the chronicle distribution of the packet's activity in your system. After that, we need to detect features. Very simple. In this example, the feature will be the timestamp, the source and destination of your IPs, the source and destination of the ports. By using these three features, we can define or make even a simple binary system. Is it an attack or not? And the third step here will be the learning module. The learning module will need the training data that will build what the module will be, and at the end, it will be the test set. Reminding from last time that all the steps that we need to get the data is to determine what we need to go, the collection, the organization, and clean before analysis. Example of a nice platform that you can have and it's still free is the Azure machine learning service. It have a very good GUI. It have a nice control center. It have a pre-processing of the raw data. Additionally, it can allow to train a machine learning algorithm, develop feature module, and deploy that feature module to Azure through something, so a tool or the API called Machine Learning Azure API. And this is how it works. This is the block diagram of your Azure machine learning. It starts by you have environment, experiments, pipelines, datasets, module, and endpoint. And all of them, they call it an asset. But before reaching to the asset, you start first to define dependency between the different accounts, different registry, key values, what's the application inside, and using them to a workspace. The workspace will be forked into things: the linked services, which is the data store and the compute target. The other side will be the managed resources, which is the compute instance and the compute cluster. For extra information, I put the link here, and you can find it also on Canvas. I want you to read this document. It's a Microsoft document that will cover the concept of the Azure machine learning architecture. But if we look at the Azure machine learning workspace, it looks like this very simple tool: drag and drop. Every rectangle of these rectangles actually a function that can use. The machine learning will go through every and each one of them in the order that you define, up and down, and it will go till you can reach even what learning algorithm to use. Every time you can click on any of these squares, it can give you more information about the parameters you can change, and you can run again, and so on. It's very usable, and I guess it will be fun to play with. And this is why in our hands-on, in the next videos, you're gonna see how we're gonna deploy simple experiments on Microsoft Azure machine learning. So I'm gonna conclude here, and concluding by saying that machine learning and cloud computing are really the rescue for the huge amount of data that we started to see in our cybersecurity systems right now. And this is why we do the data-driven cybersecurity. Remember that the training data set is the key to teach the machine learning algorithm how to interpret the data set. And remember that the first key of your machine learning is a data set, and the data set actually coming from the log or your packet activity. Some of the people are really depending on the vulnerability management system and the CMs, such like that. But it's very important to notice that the output data from these systems are really not in any standard, and they use proprietary formats. So before you start even looking at the machine learning, learn what format you're gonna feed this machine learning, so to get a successful machine learning model to protect your network. Thank you.